Hey Bobby, how you doing? Are you there? Is your video screen on? Is your audio on? There you are. Good to see you. Can you hear me okay? Good to see you, Bobby. Can you hear me okay? I want to make sure you're not there we go. All right. Can you hear me now?
Yes.
Okay, good. I'm so glad you're here. You're the first one on.
Really?
Yeah.
I didn't know if I could figure it out or not, but here
No,
I am.
you figured it out great. I'm glad
Yeah.
you're here. This is the first time we've tried this. So my goal today is just to get people on and feel like we can do this a couple times, each week, and
Mhm.
to review some simple skills that'll help you with like TABE Academy and IXL. I think today we're just going to go over greatest common factor and reducing fractions, maybe like a 30-minute lesson, and then give you some time to work on IXL and TABE. And just to see how many people could follow the link and get on. We don't know how many people have Wi-Fi access or, have a computer that has a front camera or not. So I'm so
Mhm.
glad to see you. Are you healthy? How are you doing?
Yeah, I've been doing pretty good. How about you?
Yeah, my family's been really well. My wife's a teacher too, so we're both doing this, online
Oh,
teaching with students. So it's kind of a learning curve.
yeah.
No, everyone's been really healthy and kids are doing well, and so I'm
Here
thankful.
too.
Now, are you going to work or are you quarantined right now or
No, I didn't work. I babysit my grandbabies,
okay? And so you're still
but
doing that.
no, I'm not.
You're not doing that. Okay.
No.
All right.
Um, two of my kids, well, my daughter and my daughter-in-law, they work in the healthcare field and they've shut down.
Yeah.
My daughter works at an eye doctor, and my other daughter works at a um, just like a clinic, and they
Sure.
both shut down.
Yeah. Wow. Okay. Well, let's start. And if more people, let me see. Okay, we got Elizabeth now. She's joining us. Hi, Elizabeth. Can you hear me? Let's make sure she's.
It took me a few minutes to figure out the audio.
Yeah. Start. Let's see if she's able to get on. Unmute all. There you are. Hi, Elizabeth. How are you? Can you hear me okay? It's good to see you. Welcome. Have you enabled your microphone, Elizabeth? Hopefully she'll be able to. Elizabeth, give me a thumbs up if you can hear me. You hear me okay? I'm not sure she can. Okay. All right. Well, what I'd like to do today is to start uh, with just a review of greatest common factor and simplifying fractions. And hopefully we'll have a few more people join us here. Looks like Sophia just got on. Hi, Sophia. Welcome. There you are, Sophia. Good to see you. Sophia, is your microphone enabled? Give me a thumbs up if you can hear me. You hear me? Okay. Let's make sure everyone is able to hear. Audio. Yep. There you are, Sophia. Can you hear me okay, Sophia? Okay. Okay, well, let's begin. What I'd like to do is share some things so you can see it on half the screen. You'll see me in the corner. And these are some things that we've gone over before, but I haven't seen you in a while. So the first thing that I'd like to do is go over just a review of greatest common factor with you. And I think I've got several examples of this. I think what I'd like to do is start with this one. So if you remember, greatest common factor is going to be the smaller of the two numbers, or it'll be smaller than both of the numbers, because a factor is a number that can be divided into another number. So when we look at factors, we use this to reduce fractions. So if I was looking at, so for instance, the factors of 8 over here, I know that 8 can be divided by 1, 8 can be divided by 4, 8 can be divided by 2. So I'm going to list those. Start out with the number itself. So you have 8, you have 1, you have 4, and you have 2. So these are all numbers that can fit into 8. And then when I look over here at factors of 12, I'm comparing these two. I know 12 times 1 is 12. And I know 4 times 3 is 12. And I know 6 times 2 is 12. So the greatest common factor is the highest number that fits into both of them. So when I look at factors of 8 over here, I have 1, and I have a 1 over here. So it could be 1. I have a 4, that's higher than 1, and I have a 4 over here. So right now the highest number would be 4. Now I have a 2, that's a factor of 8, and I have a 2, which is a factor of 12. Now over here, I have an 8, but over here I don't. So I'm going to cross out 8, because common means it's the same number for both of them. I have a 1 over here, I have a 1 over here. 12 has a factor of 12 over here, but not over here, so I'm going to cross that out. I see I have 6 as a factor of 12, but I don't have it on this side, so it can't be 6. So my highest number that's the same for both is going to be 4. So I'd say my greatest common factor is 4. Lots of common factors. 1 was a common factor. 4, of course. 2 was a common factor. 3 wasn't. 8 wasn't. 6 wasn't. So this is how we find greatest common factor. Let's look at another one. And if you guys have a pad of paper and you can write some of these down with me, that might help you remember it a little bit longer. And then I'm going to post this videotaped lesson onto a YouTube channel that I'm starting just for Adult Basic Ed. So if you miss a class, you can go back and watch this again. So over here, I have greatest common factor of 15. So I'm thinking to myself, what are the numbers that fit into 15? Well, I have 15 and 1, the number and 1. I have 3 times 5, that fits into 15. And I'm going to compare these factors to factors of 20. So I have 20 times 1. Of course, I have 2 times 10. I have 5 and 4. And then when I look at common factors, I'm looking at what are the same factors for both 20 and 15. Of course, I have 1. I got 15 here, but not over there. Can't be 3. I have a 5. There's a 5 for 15. And there's a 5 for 20. Not 2, not 4. 10 doesn't work. So between 1 and 5, my greatest common factor is the highest one. So greatest means highest number. So it'd be 5. Okay? Let's look at 21 and 35. So my factors of 21 would be the number and 1. 21 times 1. 3 times 7. And And my factors of 35 over here that I'm comparing it to, of course, is 35 and 1, 5, and 7. And then I'm going to look at what the common numbers are, the common factors. So 1 is a common factor. Sometimes it is 1. 21 isn't because there's no 21 on this side. 3 doesn't work, but 7 works. There's a 7 here, and there's a 7 over here. So I'm going to write 7. So now I'm going to look at what that G means. G, greatest, means the highest number. So between 1 and 7, I'm going to pick 7. Okay? I'm going to stop right here. Do you guys have any questions on these so far? Are we doing okay?
Yeah.
Any questions? Sophia, you doing okay? Elizabeth, any questions? Okay, let's scroll down a little bit and look at another one. So we have 6 and 18. So numbers that are factors of 6 are 6 and 1. And then I have 2 and 3. Then I'm going to compare that to factors of 18. So I have 18, I have 1, I have 6, I have 3. Of course, I have 2 times 9. So what are common? What are the same factors between all of these? Let's start with 1. And I've got a 6 over here and a 6 over here. So I'm going to add 6. That's a common factor. I have a 2 on this side, and I have a 2 over here, so I'm going to add 2. I've got a 3 here and a 3 here, so I'm going to add 3. I have a 9 on this side, but not on this side, so I can't write 9. But it looks like my highest one between the two of these is going to be probably 6. 6 is my greatest common factor. Okay? Any questions on that? You doing okay?
Yep.
Okay. The next thing I'd like to share with you, this is just kind of a fun presentation that reviews factors, what factors are. Can you guys see that okay? This is a Tim and Moby presentation that I want to share with you. And I want to make sure that you can see it. Let's move this over here. Come back over here. And I'm going to play this for you. You can see it down here. There we go. Okay. And hopefully the audio will be loud enough for you guys to hear this. But this is a great little review on how to find the factor of a number. Let's pull this up a little bit. You guys see that okay?
Hey, I thought we agreed on white tiles for the bathroom. Dear Tim and Moby, what is factoring? From Ramona. Well, factoring a number is like breaking it into pieces. Each of those pieces is called a factor. As you might remember from our multiplication movie, factors are the numbers we multiply together to get a product. Put another way, factoring is the process of finding all the numbers that a number is divisible by.
Including 1.
Let's look at all the different ways we can arrange 12 tiles on the wall. Here we've got one row of 12 tiles. 12 times 1 equals 12. 6 times 2 also equals 12. And 3 times 4 will get you to 12 too. Our little tiling experiment shows that 12 is divisible by 1, 12, 2, 6, 3, and 4. That means these numbers are all factors of the number 12. What can we use factoring for? I'll tell you. This wall is 250 centimeters by 350 centimeters. We can use factoring to figure out exactly what size tile we should use if we want all the tiles to fit perfectly. Okay, what are all the numbers that 250 is divisible by? Good. Now, what about 350? As you can see, some factors show up in the lists for both numbers. We call these common factors. Assuming our tiles are square, we can pick ones whose sides are equal to any of those common factors. 2 by 2, 5 by 5, 10 by 10, 25 by 25, and 50 by 50 tiles would all work. If I wanted to lay as few tiles as possible, I'd pick the biggest factor that both 250 and 350 have in common. Right, 50. We give this number a special name, the greatest common factor, or GCF. Yeah, that was just a hypothetical example. We won't actually use tiles that big. I'm glad you asked that question. You may have noticed that some of the factors we found so far, like 2, 5, and 7, are prime numbers, which are whole numbers greater than 1 that are only divisible by 1 and themselves. Since these factors are prime numbers, we call them prime factors. But what about the factors that aren't prime? That's right, we can keep factoring them until we eventually end up with all prime numbers. The process of breaking any number into its smallest whole pieces is called prime factorization. To do it, we use something called a factor tree. I think I need something to write on. Whoa. Okay, let's try 24. I usually factor 24 by thinking of it as 2 times 12. 2 is prime, so we're done there, but 12 can be factored to 3 and 4. Now we've got 2 and 3, which are prime factors, but 4 can still be factored. So the prime factorization of 24 is 2 times 3 times 2 times 2. Well, it works the same with negative numbers. Just remember that -1 will always be a factor of any negative number. Yeah, once you understand what's going on, factoring is easier than tiling a bathroom. A lot easier. Remind me not to let Mom and Dad come up here anytime soon.
So that just gave you kind of a fun view of greatest common factor. And I thought that would be kind of just a fun break to watch an animated version of that. So the second thing I'd like to do at this time is just to go back and look at a few more examples of greatest common factors, starting with 20 and 48. And again, if you have like a notepad or something that you can write on, that would be great. Elizabeth, Gudelia, good to see you. Welcome. How are you doing?
You. I'm good.
Good. I'm so glad you could join us today. So I'm looking at 48 and 20 here, and I want to make sure that I'm going to find the highest number that fits into both of those. So if I'm looking at 48, for instance, I'm going to make a line here. I'm going to say 20 is up here and 48's down here. And I'm going to think of all the numbers that fit into 20 and 48, and then I'm going to pick the highest one that's the same for both, okay? So for 20, I have, of course, the number 1. And for 48, I have the number 1. But I know that I can factor 20 by 2. I can factor 20 by 10, by 4, and by 5. I can factor 48 also by 2. 2 times 24 is 48.
Mm-hmm.
I can factor 48 by 6 and 8. And I'm looking at which ones are the same between those. What's the highest number that's the same between those? So for 48, I can also have the factors 12 and 4. So those are my factors. Now I'm going to look at the ones that are the same. I have 1 and 1, 2 and 2. Do I have a 24 up here? No, so I'm going to cross out my 24. That can't be a common factor. I've got a 6 down here, but I don't have a 6 up here, so that can't be a common factor. So I'm going to cross that out. I have an 8 on the bottom, but I don't have an 8 for 20, so it can't be 8. I'm working my way through, aren't I? I have a 12 on the bottom, but 12 is not a factor of 20, so it can't be that. But I've got a 4 here, and that's higher than 1 or 2. And I also have a 4 as a factor up here. So I'm going to say my greatest common factor for 20 and 48 is 4. Does that make sense? Any questions on that one? Are we doing okay?
Yes.
Okay. Let's look at 60 and 24. So I'm going to do the same thing here. And if you have a pad of paper, you can do this with me. I'm going to write 60 down here, and I'm going to think of all the factors that fit into 60 and 24, starting with 1. So I know 1 is a factor of both. And for 24, I know 6 times 4 is 24. Of course, I know 8 times 3 is 24. And I know 2 times 12 is 24. So I'm going to write all those down. And then I'm going to do the same thing for 60. So for 60, I know 2 times 30 is 60. I know 15 times 4 is 60. I know 20 times 3 is 60. Of course, I know 6 times 10 is 60. And then I'm going to look at the numbers that are the same for both. So I have a 1 here and a 1 here. I can keep that. 6 is a factor of 24, and 6 is also a factor of 30, so I can keep 6. 4 is a factor of both, so I won't cross that out. 8's a factor of 24, but is 8 a factor of 60? No, so I'm going to cross out 8. 3 is a factor of both. I have a 3 here and here. 2 is a factor of 24 and 60, so I'll keep that. 12 is a factor of 24. Is 12 a factor of 60? Yes. Yeah, 12 times 5 is 60. So I'm going to add that over here. So I'm going to keep my 12. So I'm looking at all these. What's the highest one that's the same for both? I think it's the 12. There's a 12 here. 12 times 5 is a 6. Yeah, so I think this one's going to be 12. So a lot of students will say, well, Mr. Ramsey, so what? Keith, why are we teaching this? Well, it's because we use factors to reduce fractions. So if I gave you an example of a fraction here that's not reduced, it might look like, let's see here. It might look like this. Let me pull this over where you can see it. Can you guys see that okay? And let's pull this over a little bit. Okay, so let's say you had the fraction 10 over 40. I know this isn't simplified because the greatest common factor of 10 and 40 needs to be divided into both of those to reduce it. So if I had 10 over here, let's pull up my pen again. Okay, let's say I had 10 over here. I know my factors of 10 are 10, 1, 2, and 5. And I know my factors of 40 are going to be 40, 1, 2, 4, and 5. What's my greatest common factor between 10 and 40? You guys see what it is?
No.
I've got a 10 here. I got 10 times 4 is 40. So it's 10. So if I divide the top by 10, I'd get 1. I'm using the greatest common factor. If I divide 40 by 10, I'd get 4. So by using the greatest common factor of 10, if you divide the top and the bottom of a fraction, the numerator and the denominator, by the greatest common factor, that's how you reduce the fraction. So that's the impetus of teaching this. If I wanted to reduce 8 over 10, I would say, well, what's the greatest common factor of 8 and 10? I know 8 is divided by 8, 1, 4, and 2. And I know 10 is divided by, of course, 10, 1, 2, and 5. What's the highest number that divides 8 and 10? Do you guys see it? What do you think? Is it? I think it's 2. I have a 2 here And I have a 2 over here. So if I divide the top by 2, I would get 4. If I divide the bottom by 2, I'd get 5. So 4/5 is my reduced fraction, and I reduce it by using the greatest common factor, okay? So it's good to see all of you. I'm gonna be counting this for your attendance today, and I wanna give you a little bit of time to work on TABE Academy and to see if you guys can get on IXL. And I see that we have 1, 2, 3, 4, 5 of us here today. That's excellent for our first video conference. That's really good. So I want to take a minute and just ask how you're all doing. How's everybody doing? You guys staying healthy? Are your kids healthy?
Yeah, everybody's good.
Everybody's good?
Yeah,
Yeah,
doing great.
Well, I've missed
they're
you.
good.
This wasn't my plan for April and May, but
I'm sitting downstairs.
this is sort of what happens. Although I do like teaching you on my patio. This is kind of nice.
Mm.
It's not so bad. All right, so I want to do the same thing next Monday. I want to teach you the same way. Probably we'll do distributive formula next Monday. And hopefully we'll get all of you back here again. If you had any trouble with your microphone or your video camera working, just log in a couple minutes early and we can work those things out before we get started. So I hope to see you again on Monday, okay? Same time, same, I'll
Okay.
send you a link, I'll send you an email. I'll try to text, I have a lot of your text, your phone numbers for texting. And I will count this toward your attendance. I'm so glad that you're able to get on today.
Right.
I see quite a few of us got on today. This is great, 6
Nice.
of you. All right, so
Nice,
I'm
nice
gonna let
seeing
you
teacher.
go. And all of these will be tape recorded. So if you wanna come back and look at a video and just review it, I'm gonna start a YouTube channel just for our adult basic ed class. And I'll send you the link for that. And then all of
Okay.
these recorded sessions that we have today, I'll put on that YouTube channel. So there'll be one on
Okay.
greatest common factor, there'll be one on graphing, there'll be one on fractions, you know, adding, subtracting mixed numbers, and what have you, percents, decimals, but we'll start building a library of videos using this, okay?
Okay,
Have a great
teacher.
evening, you guys. Bye-bye.
Bye.